Okay, so as always, the lectures are recorded and they will be posted to YouTube by the end of today. Okay, so if you want to review anything, just follow that link. You'll see it's the latest video in the playlist. Okay, so we're going to go through these two problems from yesterday. So I left them as homework for you to try out. A few of you said you tried them, which was good. So let's go through it. So for the first one, we want to prove that statement using a truth table. So we're going to have a truth table for the left-hand side, a truth table for the right-hand side, and we just need to check that they match up. So let's start with that left-hand side. We've got two variables, A and B, and we've got a bracket there. So brackets A or B, that's going to be one column, and then not the bracket A or B, that will be another column. Okay, so that gives you the idea of how to set up the table. So you look at the expression, you break it up into parts, each part will be its own column. Okay, so let's have a look at the left-hand side. Okay, no, phones need to be switched off during lectures. Okay, so let's start with the left-hand side. So we've got A, B, A or B, we can make that its own column. And then finally, not A or B, we can make that the last column. So we set it up. We've got two variables, so we're going to have 4 rows to deal with. So let's write this true, true, false, false, true, false, true, false. Right, same as we did last time. Now, A or B, let's fill that in quickly. Everyone knew it last time. So let's go through it. The first one. Next one. Next one. Next one. Perfect. Now, not A or B, we discussed this last time. It's the opposite of whatever we have here. So not true, it can be only one thing, false. Not false, it can only be one thing, true. So let's go through that. First one. Yep. 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 Perfect. Okay. Very quick and easy. So that's the left-hand side. So here we see false, 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 true. This is what we should get for the right-hand side as well. So we have A, B. This one has a few more columns. We're going to have not A, not B, and then the combination of the two. Okay. Everyone see how we set up the table? So we broke it up into parts. Each part is going to be its own column in the table. Okay, same as before. 2 variables, so we have 4 rows. So it will be true, true, false, false, true, false, true, false. Not A, not B, that's just going to be the opposite. We can fill that in quick. So true becomes false, true becomes false, false becomes true, false becomes true. Then not B, very similar. True becomes false, false becomes true, true becomes false, false becomes true. And finally, the last column, we're going to AND these together. So first one, false and false. Who says true? False and false is? False. False. Good. False and true? True and false? True and true? Now we check that it matches. So first one, false, 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 true. Second one, false, 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 true. Okay, they match up. End of proof. Any questions so far? Yes.
So, what is combination is the autonomous information?
Complement.
So, it's information A and
Yes, we'll get that later with the set theory proofs. But remember this, there's no sets or anything. It's just true and false. There's no sets or anything here. So A and B is just true and false. Later on, this A will be A is an element of a set. This will be B is an element of a set. But for now, we're just looking at A and B. Yep. So that's proof of 1. Do we need to go through proof of 2, or you okay with that? Okay, hands up if you want me to go through it. Okay, let's go through it. Okay, so for this one, it's going to be not A and B. So we want to set up the table. So A and B can be one column, not A and B. That will be the last column. Is everyone clear with that? Okay, so let's go through it. So we have A, B, A and B, and finally not A and B. Okay, so that's just breaking up this left-hand side into the two parts. So we do the brackets first, and then we do the knots at the end. So true, true, false, false, true, false, true, false. Okay, A and B, let's quickly go through that. First one, next, next, next. Yeah, sounds like everyone knows what to do. And then next column, not A and B, so we take the opposite of whatever's here. So let's go through that one, first one. And then all the other ones will be true. Okay, everyone clear for this one? Let's have a look at the right-hand side. For the right-hand side, we're going to need a column for this part, for the brackets, a column for this part with the brackets, and then the last column combining those. True, true, false, false, true, false, true, false. So not A, that's going to be the opposite of that first column. So that will be false, false, true, true. And then not B, that will be the opposite of that second column. So that will be false, true, false, true. And then finally, the last column is the OR of these two columns over here. So first one, next one, next one, next one. We look at the last column. So false, 3 trues. False, 3 trues, they match. So that's the end of the proof. Is everyone okay with that? Yep. No, we can clearly see the last 2 columns match, so it's fine. Yeah, you don't need to write anything. You can see they match, I can see they match, you get the tick. Okay. Yeah, you don't have to explain anything. I can see. As soon as you set it up when I'm marking, I see, okay, columns match, everything's fine. If you're writing the test and the columns don't match, well, then you need to redo it. Yeah, then there's something wrong. Okay, everyone okay with this? Yes.
So, kind of, do you know when you know where my six fine?
Yes.
I think I have sets behind these.
Yes.
These are intricate, still remaining coming.
Okay.
That's tools.
This part over here. Is it this part? The set operations.
Like, you can't, like,
Set difference. Okay, so what we're doing is we're taking the larger set A and we are removing the elements of B, right? Like minusing them. So we take set A. So this is A. Inside A, we have set B. Okay, right? and we're doing the difference. A minus B, we're taking it out. So this shaded part in red, we take out. So if I pick some element now, it's going to be inside A, right? So X is an element of A, it's inside the box, but B has been removed. So can it be an element of B if we remove it? Not element of B. Make sense? So it's inside the box, but not in B. So it's inside the box and not in B. You just read it exactly how it goes here. Okay. So again, you're in the box, but B has been removed. So we scratch it out. So you're in the box, but not in B. So you're in the box and not in B. You just read it like that.
Let's sign this A minus B the equivalent to ask. I don't understand it.
It's just notation. It's just two ways of writing it. So you can write, I prefer this one because it's like a minus. But in the textbook and the notes, you might see it like this. But if you want, I prefer that you stick to the minus. Okay, it makes more sense because you're minusing it. Okay. Also online, some YouTubers and stuff, they might write it like that. So just don't confuse that. Okay. Anything else? Okay. So let's get back to the proofs. Okay. So over here, please put this in a big box now. So we're going to have the distribution law. Okay, so this is very, very important. You have to memorize these. So the distribution laws, we looked at it last time. We proved them. I didn't call them distribution laws. I didn't want to give them a scary name yet. But what we proved yesterday, those are the distribution laws. So it is A and B or C is equal to A and B, or A and C. Remember these from last time? We proved those two statements. So it's this one and the other one, A or B and C, is A or B and A or C. Okay, please put a big box around that. Okay, so it's not too difficult to remember these. It's called the distribution laws because these ands and ors behave very similar to pluses and times, right? So let's have a look at this. Think of this and as like a multiplier. Okay, so we have A and we have brackets. What do we do with brackets? We distribute inside. So A and distributes to B. A and B. Think of the or like a plus. We have A and C. A and C, and we've got like the plus in between. Okay. So again, think of the and like a times and the or like a plus. We have A. Yeah. Okay, it's not exactly a plus and a times, but it gets the idea across. That's do you see the idea of the distribution? Yes, no? Let's try this other battery, see if we have better luck. Okay, there we go. Okay, so this is just a little side thing. So think of the and as a times. So we have A times B plus C. How would you distribute that? It would be A times B. And then you would have a plus, and then you would have A times C. You see how it matches up with that? Okay, so ands, think of it as a times, ors, you think of it as a plus. And then this one, very similar. So A or B and C. So it will be A or the first one, and A or the second one. Again, it just distributes inside the bracket. So A or the first one, and A or the second one. It distributes like that. Okay, so you can write it like this. So it distributes to the first one, distributes to the second, distributes to the first, distributes to the second. And then you get these two brackets here. Everyone clear on that? Okay, please put a big box around that. That is the distribution laws. Okay, and then together with the distribution laws are the De Morgan's laws, which we looked at yesterday and we proved just now. So this and De Morgan's laws. So this will be not A or B is equal to not A and not B, and then not A and B is not A or not B. Okay, please put a big box around this one. Okay. Please make sure you know these four laws. If you don't know them, you can't even start with the set proofs. Okay, so these are very, very important. And again, there's a little bit of distribution going on. So this or on the left here, after distributing the not inside, it becomes an and. And then the same thing for the other one. So the not being distributed onto the and, that becomes an or. Okay, is that all right? Oh, yes? Sorry? Lost where? Okay, I'm fine with people saying that they lost. You need to say where you lost, so I know where to go. Okay, because lost could mean I'm lost from Monday's work. You know, where did we lose you? No laughing. It's fine to be lost, but we need to get them back with us. Okay, where did we lose you? The start of De Morgan's laws. Okay. So this is what we proved a couple minutes ago with these. Right, these De Morgan's laws with the truth tables. Was that okay? The truth tables you don't know. Okay, you're gonna have to see me afterwards. Okay, because when I did the truth tables and I said, is everyone okay? Everyone said yes. Okay, if you have a problem after that part, you must put your hand up and say, I'm lost. Then I can do it again. Okay, but now we've moved on too far. You're gonna have to see me afterwards. Okay, remember yesterday when I said, please speak up. We're going to move quickly. It is very easy to get lost. This is an example. Now we're already starting the proofs. It's too late to redo the truth tables. Okay. Does everyone understand? Now you're going to have to see me afterwards. Okay, so we have the distribution laws, the De Morgan's laws. Please put boxes around that. And then from yesterday, these rules over here for the set operations. Okay, either rewrite it and put another box around that, or go to the previous page and put a box around that. Okay, so please make sure you have those three things with big boxes around them. The set operation rules, De Morgan's laws, and the distribution laws. Okay, those three boxes we're going to be using heavily in this next section. Okay, so next section, set proofs. Okay, so like I said before, quite a lot of the assessments will be proof-based. So for this chapter on set theory, the proofs will only be on sets. Okay, no other proofs. When we get to functions, the proofs will then be on functions. Okay, and so on. Okay, so set proofs. We're going to start off with a fairly simple one. and then we'll get into the more complicated ones. There's about 12 over here. We'll see what we get through. The rest will then be for homework. Okay, so number 1. We want to prove that B minus A is equal to B intersection with A complement. Okay, so that is our set identity. Right? You've seen identities before, trig identities, all of that. These are set identities we want to prove. Now, the way we're going to do it is the same as you prove those other identities. You start with the left-hand side, you do all your stuff, show it equals the right-hand side. Yeah. Question? Okay, good. So we start with the left-hand side. We're going to write it out using the set rule for that. Do a bit of calculation, and we're going to get to the other side. Yeah? You here for MATH160? Yeah. Okay, sure. Find a seat. Okay. So let's start with the left-hand side, see what we can do. Okay, so we start with that. Now, what we're going to do is expand this out using that definition. Remember, this is just the symbol for the set builder notation. So we're going to expand it out. So this is a set. The whole thing is a set. And we write it as X such that X is an element of B and X is not an element of A. Yeah, that is from that first box that we have there for that definition. Now, what we want to do is look at this for a little bit and try to get to this. Okay? So if X is an element of B and X is not an element of A, what is X an element of? If it's not an element of A, then it's an element of the complement. Exactly. Yeah. Does everyone see that? X is not an element of A means X is an element of A complement. Okay. That was like one of the very first things we did in the lecture. Now, what do we have here? X is an element of B and X is an element of A complement. What does this and mean for these two? Intersection, exactly. But this is just a very silly way of writing this set over here, because it's X such that X is in the set. Well, then it's just a set. And we're done. Okay. Does everyone see the logical steps there? Okay. This is no time to be shy. When you get to number 2, there's going to be tears. Okay. There's always tears with number 2. Okay. So please, everyone okay with number 1? Okay, good. Okay. Who says no? Yeah. So lines 1, 2, 3, 4, 5. Where did we lose you? From the? From the start. From here. Okay, so we've got B minus A. What we used over here is the definition of B minus A. That's from lecture 2 over there. Right? We just used this definition. Okay, is that okay? Okay, so that's the first thing we did. Number 1, we used the definition of B minus A. Then we looked at the second part. X is not an element of A. If X is not an element of A, it must be an element of A complement. That's from lecture 2, right at the beginning. There. X is an element of S. If X is not an element of S, then it's an element of the complement. Okay. So that's from the lecture 2 there. That was number 2. And then finally, X is an element of B and X is an element of A complement. We go back to lecture 2. That is the definition here for the intersection. x elements of A and x elements of B, that's the intersection. So that's number 3 that we used. Okay. Is that all right? Okay. Anyone else lost before we get to number 2? Okay. Let's have a look at number 2. So here we have B minus A union C minus A is equal to B union C minus A. So this is another identity. Okay, there's like hundreds of these. Okay. So a lot of examples to work through. So what we want to do, same as before, we start on the left-hand side, expand it out using the definitions, simplify, and we hope to get to the side over here. So left-hand side. So this is going to be all of the x such that this is a union. So any x must be in here or in here. Okay, that's the definition of the union. Union goes with or. Now here we have set difference, and here we have set difference. So we're going to use the definition of set difference for this one and for this one. Okay, so set difference means it belongs to the first one, but not the second one. Same thing for this one. Set difference means it belongs to the first one, but not the second one. Yeah. Make sense? Now here, to answer your question from earlier, yes?
That subtraction sign symbolizes and or
It's this whole thing. It's this subtraction here is x is an element of the first one, but the minus means we're taking this out. So it's not an element of the second one. Yeah, because we take it out. It's not an element. Okay. And then to answer your question from earlier, this x elements of B, let's put that as a B. We just write it as a B, right? Because x elements of B is true or false, right? So we put a B. X not elements of A, let's just call that A. X elements of C, let's call that C. And X not elements of A, let's call that A. So here we have and, or, and another and. What is this? Distribution, exactly. So this is distribution. Let's go back here. So you go back to your big box with the distribution. It's this first one. We have A and B, or A and C. So what we can do is rewrite this distribution law we have like this. Okay. So just keep this one in your mind. So we have this. We're going to rewrite it like this. Okay, so this is going to become x elements of B is the or, so it will be or this next one here. Then we have the and x not elements of A. Okay. Does everyone see the distribution we used? We have a A over here. We have an A over here. We took it out to the side. So we can rewrite it in pink again. So this is B or C and A. That's exactly the distribution law. Yeah.
It's asking the camera, but this is not six elements of A is X is an element of A complement, right?
Yes, yeah. We're going to do that now. Yeah, so this you can write as A complement if you want. But now we're going to just simplify a little bit more. So X elements of B or X elements of C, what does this mean? If it's in one or the other, it's in the union. Yeah. So finally, we've got X elements of the union and not in this one, or in A complement, if you want to write it like that. So it's in the union and it's not in this one. What can we rewrite this as? So it's in the union and not in this one. We can write it like set difference. Right. This right-hand side is always what we're aiming for. We're always trying to get to that. So it's in the union and not in A, so we can just subtract A. Okay. Okay, I don't see any tears, so that's good progress. Any issues with this one? Yep.
Please explain from the third last line where you will B, the C, and A distribution.
Oh, from the distribution. Sure. So we are using this distribution here. Okay. So we started with this. The X not element of A, that was repeated twice. So just have a look at that line. So you have X not element of A and X element of B, right? That was the one term. Or X not elements of A. Have a look in your notes. X not elements of A and X element of C, right? The X not element of A is repeated twice here. So what we did was we took it out and we wrote it in front here as X not element of A and, again, look at your notes, X elements of B or X elements of C. You see the rewriting? Okay. So this part here was repeated. We took it out to the front. Okay. Everyone see that? Okay. So again here, this part here, that was repeated in both brackets. So distribution tells us we can take that out. Okay. Any other questions before we move on? All good. Okay, let's have a look at another one. So that was number 2, number 3. Okay, so we've got A complement, union B, intersection with B complement, union C is equal to A complement, union C. Okay. Looks a bit messy, but we know the definitions for each of the parts. Unions we know, intersections we know, complements we know. So we're just substituting what we know. So let's have a look here, left-hand side. So this is going to be A complement union B, intersection with B complement union C. Okay. In between the two, we have an intersection. So that's going to become an AND. So X is going to be an element of the first part, and X is going to be an element of the second part. So the intersection became an AND. Now let's expand the unions on both sides. So here we have a union, so it's in the first one or the second one. Here we have a union, so it's in the first one or the second one. sorry, union becomes OR. Okay, so we have that. And always remember, okay, if you get lost, going through, you think, okay, I don't know where to go from here. Always look at this side here. Okay, this is what we're aiming for. Notice that this side no longer has the B. So somewhere in our calculation, that needs to cancel. Okay, so that gives you a hint. So we started on that side. We're trying to get to this side. There's no B on this side. So when we expand everything out, that should go away. Okay, so let's try to do that. Okay, so if X is an element of A complement, or X is an element of B, we have that as one term. And X is an element of B, or X is an element of C. Okay, we've got or here, we've got or here, and an and between them. What can we do? We want to, expand everything out. So what can we do? Distribution, exactly. So we can have this term distributing onto all of these terms. Do you see that? The or is a plus and the and is a times, right? So we can distribute like that. So let's distribute the first one over like the times. So it will be this one and this one. Okay. Okay. And then it will be this one and this one. Right? Normal distribution. So we've got the first term in brackets, the next term, then it will be this one and this one from the distribution. And finally, it's going to be this one and the last one we have here. Okay. Does everyone see the distribution? Okay. Now let's have a look at this one here, the one with the two B terms. We are saying X is an element of B and X is an element of B complement. Can this ever be true? Can you have X being an element of B and X not being an element of B? No, that's always false. We can cancel that out. It's always false. Yeah. You see what we did there? Yeah. The step, yeah. The distribution. Okay. So we're doing the distribution. So it will be this one with that one. That gave us this first bracket here. Then it will be the first one and the second one. That will be this next bracket here. Okay. There. Then we did the distribution for this one. Like your foil, whatever you call it. So then it will be there and there. Yeah. And then that gives you the four terms. Yeah, exactly. Yeah. Okay. So we have X is an element of B and X is not an element of B. That's always false. So we can put a big F there. So that's always false. Okay. So what we want to do now is try and combine this bracket and these brackets over here to get this. So we need somehow to get X is not an element of A or X is an element of C, right? That's what we're aiming for. So looking at this, what can we do next? So now it's up to you. So we've got these three. And we only have two distribution laws. We have two De Morgan's laws. That's all we have to work with. Okay. Everything in between here is distribution or De Morgan's. There's four things to choose from. So what can we do with this bracket, and this bracket? Yeah. Okay, sure. Look for things in common. Okay, like the distribution. Remember the A was common. If we go back a little bit, over here, we have A over here. We have A over here. That was common to both brackets, right? We could take it out to just one A out here. We have an A over here. We have an A over here. We can take it out over here. Okay, so look for those patterns. What is common between this bracket, and this bracket? The A complement. That's right. Yeah. So we have A complement over here with this and with this. But this B complement and C, do we really want those together? No, we don't want those together. Why? Because we want these two together. Okay. So let's look at something else that's common. Exactly. These two are common. So we can take that out. Very good. Now you're catching on much quicker than my last year. Okay, that's good. Okay, so this first one we're going to just leave alone. Okay, we'll leave that there. Okay, four. And then these two, we're going to do the distribution. So which one was common? C. So we're going to leave that out there. And what's left? The A complement and the B. Everyone see what we did there? The C here and the C there, we took out to the side here. Okay. Now, almost there. So now we just have this bracket here and this bracket here. What can we do? Sorry? It's always distribution. Yeah. So what can we do? What we want is these B's parts to go away. So we're left with the X as an element of A complement. That will be the first thing. Or X elements of C. So what do we get? We get this. Okay, so what can we do in terms of distribution to get the A complement by itself or the C? What can we do? Always look for what's common between the two brackets. Oh, someone said it? The A complement. A complement is over here, and A complement is over here. Okay. So when we take it out, what's left? B complement and B, which we can get rid of. So what's left after the distribution? A complement or C. And what does that mean? Or becomes union. Exactly. Okay. So we take out the A complement. Okay, I'm not going to write all the B's. We had it from before, it just cancels like that. And then that will give us A complement union C. Okay. Yeah, very impressive. Okay. Any questions on this before we move on? Yeah. Sorry, guy behind. Yeah. The last step over here. Yeah, so over here we have x elements of A complement. That just becomes A complement. The OR becomes a union, and then the C is just a C. Yeah. Yep.
So it's fine if there's both, or there's something common in both brackets. It doesn't matter if one is and for and the other is also for.
Yeah, we're just using this one because remember, it works for both. You can have ands and ors, ands and ors. It covers both cases. Yeah. Yeah, so you can call it distribution 1 and 2, but you're just swapping ands and ors. It's the same distribution. Yeah. Anything else? Yep.
Yeah, from the shape of the reference on.
From here.
Yeah.
Yeah. So all we did was change the intersection over here to an and. Yeah. So it's just intersection to and. We expand out the two brackets. We did the FOIL or whatever you call it, binomial stuff. Simplify, and then we left with these two. Yeah. Yeah. So it's just foiling out the two brackets and then cancelling that cross term and then simplifying with the distribution. Okay. So homework, just go through this again, step by step. Just make sure you understand, where we did distribution, where we did cancelling, where we put terms together. Just make sure you know all the parts. Okay, let's do one more, and then I'll leave you with a homework problem. That's number 4. So we have A Cartesian product B intersection C is equal to A Cartesian product with B intersection with A Cartesian product with C. So now we've got these two operations, intersection as well as the Cartesian product. Okay, same as always, we start with the left-hand side, or you can start with the right-hand side. It doesn't really matter. Let's start with the right-hand side just to make things a little different. Maybe homework, you can start with the left. Okay, so we're going to start with the right-hand side just to do something different here. So we have x, okay, such that x is an element of, well, here we have an intersection, so x must belong to the first one and the second one. Does everyone see that? The intersection will become an and. Now, what does it mean for x to belong to a Cartesian product? Remember, the Cartesian product was the set of coordinate pairs, right? You had the A from the first one, A from the second one. So we can write this x over here as x1, x2. It's a coordinate. Okay, so you might not have done this in high school, but coordinates you can just write as variables, right? It's just a variable. So x1, x2, that's our x. So if it belongs to the Cartesian product, then the first one belongs to the first one, and the second one belongs to the second one. Yeah. So the first part of the point x goes to A, the second part of the point x goes to B. And we can do the same for the second one. The first part of x will belong to A, and the second part of x will belong to C. Everyone see that? Oh, who says no? Okay. So what does it mean to belong to the Cartesian product? Remember, we had here A cross B is all the A comma B, where the A belongs to the first one and the B belongs to the second one. Right? So here, this X we're going to write as X1, X2, or you can write it as A comma B. Right? It's up to you. So the first one belongs to the first set. So X1 must belong to the first set. X2, that's the second one, must come from the second set. And then same for this next one. X1 belongs to A for the first set, and X2 belongs to C. That's for the second set. Okay, make sense? Who says no? Did I hear it? Yeah?
It's going to start.
Sorry, from where?
First.
The first step. You have to call me out when I started the first step then. If I'm 3 steps later and I have to go back, it wastes a lot of time. Okay, so if you're having trouble on the first step, immediately put your hand up and say, sir, I'm in trouble with the first step. Okay, don't wait for 3 steps later. Okay, so here we have the Cartesian product. Okay, because we're starting from the right-hand side. So we have some set, this one, intersection with some set. What does intersection mean? And. So X is an element of the first one I circled, and X is an element of the second set that I circled. You see that? Intersection becomes and. Now, what does Cartesian product mean? It means the first one comes from the first set, and the second one comes from the second set. X1 goes with A, X2 goes with B. Now we look at this side. Cartesian product. The first one goes with the first set, and the second one goes with the second set. Make sense? Okay. So we're all caught up. Now, what we have here is a lot of ands. They're all being anded. It's like multiplication, right? If I tell you A times B, is that the same as B times A? The order doesn't matter. So if I have A and B and C and D, it's like multiplication. The order doesn't matter. I can rearrange it however I like. So what I'm going to do is drop the brackets and just have everything on one line. It'll make it a bit easier to see. So X1 elements of A and X2 elements of B and X1 elements of A and X2 elements of C. Okay. Did everyone see? I just dropped the brackets because the ordering doesn't matter. Now here I have X1 elements of A and X1 elements of A. It's repeated. So what can I do? Yeah, I can just write it as one term. Exactly. So this is going to be X such that X1 is an element of A and X2 is an element of B and X2 is an element of C. What does it mean for X2 to be an element of B and X2 to be an element of C? And means intersection, exactly. Yeah. Finally, the first part belongs to A and the second part belongs to this. What does that become? First part goes with the first set, second part goes with the second set. So it's 2 different parts. That becomes. It's not intersection because these are different. Cartesian product, yeah. So the first one goes with A, and the second one goes with B intersection C. This is the Cartesian product. Right? Does everyone see that? Because the first one goes with this Cartesian product, the second one goes with this. Okay. Okay, you got it. Okay, good. So I'll leave one more for homework, and then we'll call it a day. So number 5, this will be for homework. So we have A cross B, intersection with C cross D is equal to A intersection C cross B intersection D. Okay. So that one's for homework. Please try that out. Okay, just one note for the quiz next week. There will be 10 MCQ questions on everything that we've covered this week. So the last lecture and this lecture, set theory and logic. Then there will be 2 written questions on what we covered today. Okay, so De Morgan's laws, the distribution laws, and the set theory proofs. Okay, it will be 2 of these. Okay, so please make sure you go through the tutorial. So if we go here, tutorial on sets. Okay, so the quiz, that will be on that first part there, your set operations, all of that stuff we did in the last lecture. And then the 2 written questions, that will be from here. Okay, on the set theory proofs. So you can see we've done, I think the first one, we did something similar to that. These other ones, please try them out. Okay, 2 of them, 5 marks each. That will be 10 marks for the written. Okay. Any questions for the tutorial? You're all good. Okay, so that'll be it for today.